read the laws of logic, the propositional equivalence, and today we shall begin the formal study that how we can use the implication to valid that one or the to check the validity of the propositions, or in other way we can tell that given an argument whether that argument is valid or not by using the implication whether we can tell that thing. So, it is the logical implication which formally we can tell that finally some will be giving some rules of inferences. So, let us consider one implication, the general form of implication. Let P1, P2 to Pn, these are primitive statements, and the conjunction of these n primitives, this implies Q. We call that this is an argument. This is an argument. Now, whether this argument is valid or not. Now, one thing is that why we will be reading this thing? What is the importance of the validity of the arguments? Because our main objective is that to give some mathematical proofs. So, when this logic will be applying to prove theorems, so that time we will be seeing that given one argument or given some compound propositions whether it is valid or not. So, if we explain this implication or the argument, what we see that we have n number of, n is a positive integer, n number of primitive statements. Say P1 to Pn. Now, since they are logically connected with the connectives and, that is conjunction, they are connected with the connectives and is the logical connectives. So, if each of the Pi's, that means each of the primitive statements P1 to Pn, they are true, then the left hand side will be true, since it is a conjunction and then Q will be true. So, if each of P1, P2, Pn is true, then Q is true. Q is true, so it is valid. When it will be invalid, or even if we consider the, so it is we remember that the implication truth table, that P implies Q, that if it is these are PQ, then result is true, it is TF, then it is false. If it is FT, then it is true. If it is FF, then it is true. So, only this is the case where it will be giving a false result. It will be giving a false result. Okay. Now, we see that when it will be giving a false result, that means if any one of P1 to Pn is false, since they are connected with the conjunction AND. So, then also Q is true. Why? Because the left hand side becomes F and F implies T if Q is true, then this is actually by default it will be true, that is it is vacuously true, or by default it will be true. So, we have to check the validity of the argument, that means if we see that what is the conditions or on what cases that this becomes always, the argument is always true, argument is always true. Last day we have read that if the result is always true, or if we see the compound proposition is always true for all the assignments of its primitive statements, then it is actually a tautology. So, we can, so one way of establishing the validity of the argument is to show that the implication that is general form, that P1, P2, Pn to Q is a tautology. And we can tell that then it is a valid statement, or this compound proposition is valid. Okay. So, we take one example. Let PQ word denote the following propositions. What are the propositions? Say P, I give that Amit studies. Q, Amit plays football. Or Amit passes discrete structure course. Now, we see the take 3 compound propositions. We take 3 compound propositions let be denoted by capital P, capital Q and capital R. Now, I write the statements of the compound proposition. Say P is if Amit studies he will pass discrete structures. Q, if Amit does not play football, then he will study or Amit failed in discrete structures course. Now, we have to determine whether the following argument is valid. That means, the argument we write our conventional form that P and Q and R, this implies small q. Okay. Now, small q is, these are the compound propositions, and when they are connected with the logical connectives conjunction, which implies q, and q is the Amit plays football. So, we have to check this thing. Now, last lecture we have learned the substitution law. So, we can apply the substitution laws here. That means, before that we write the compound propositions in terms of our primitive statements. So, what is P? P is, if Amit studies, he will pass discrete structures. Amit studies is small p. So, small p implies R, because he will pass discrete structures is quickly we see the previous thing. R is Amit passes discrete structure course. Amit passes discrete structure course. So, this is Q, the compound proposition Q is, if Amit does not play, that means negation Q, then he will study. So, it implies he will study means it is P, because Amit studies is small p. Then what is R? R is Amit failed in discrete structure. So, Amit passes, that was the primitive statement, small r. So, Amit failed, so it will be negation r. So, now we replace the capital P, Q and R. So, if we start with the compound propositions connected by the conjunction, so it is equivalent to P, we write small p implies R, then and Q is negation Q implies P, R is simply negation R. Now, we can apply our laws of logic here to simplify, to check the validity of the given argument. So, we apply the commutative thing. So, we can write P implies R, I can take negation R first and then negation Q implies P. So, we continue to next page. This is equivalent to P implies R and negation R and negation Q implies P. So, we have applied our commutative law. Okay. Now, what is P implies R? Last day we have seen that it is with the propositional logic, this is becomes the P implies Q, P implies Q is equivalent to negation P or Q. So, I can replace, this is P implies R. So, this is negation P or R and negation R, and similarly I can apply here also the implication that negation of negation Q. So, this becomes, because negation of negation Q or P. So, it is equivalence. Equivalence of implication. Now, I can associative law we can apply. So, negation P or R and negation R, we can apply R and negation R, double negation. So, this becomes Q or P. So, here we have applied two rules, one is our associative, one is associative second is or double negation. Now, R and negation R, this is always F. So, negation P or F. And this becomes Q or P. Okay. So, now this is equivalent to, since it is OR, so this becomes negation P, and here also I can apply Q or P is same as P or Q. Okay. So, we can similarly we can apply that here R and negation R is equivalent to or F, and here some commutative. So, this becomes again associative negation P and P or Q. Already we have just now we have used that negation P and P is F, F or Q. So, this is equivalent to Q. So, our that PQR, P Q R connected with conjunction implies small q, that is it is valid, it is valid. Now, we see that to check the validity, we have used the propositional equivalence as well as the laws of logic. Now, today we will see that whether we can still simplify it or a group of laws of logic can be combined to apply the or to check the validity of the argument, that means mainly the implication, because our argument validity of argument we have defined whether some implication is a tautology or not, or it is valid or not. So, here we have seen using the laws of logic. Now, if we remember the definition of tautology, that our final result or the truth value of the compound proposition, that should be always true. So, the same thing we see that our compound proposition was that P conjunction Q conjunction R, it was equivalent to P implies R and negation Q implies P and negation R. Now, we see that whether it is a tautology or not, whether it is a tautology or not. So, we do the truth table and see the thing. We make the truth table. So, we have 3 primitive statements PQR, Okay. If it is a tautology, then we have to write in a different way that just a minute. We can write that P implies R and negation Q implies P and negation R, whether this implies Q. This we have to check. So, I need P implies R, then I need negation Q, so that we can compute negation Q implies P, then I have negation R, then I can calculate that P implies R, negation Q implies P, negation R, and then if I mark this thing as a S, say I apply this S is P, Q, R. So, this is S, then whether S implies Q. So, I take all assignments, I take So, I take all assignments of P Q R, then whether P implies R, that means this T implies T is true, T implies F, only this is false, again this is true, again T implies F, it is false, then all it is F. So, all are vacuously true. So, if P is F, I can directly write these are all true. Now, I have negation Q. So, negation Q is F, T, then again F, T. Negation Q implies negation P. So, negation Q, this is F, whenever these two are F, it is vacuously true. Now, T T, so they are true, again this is vacuously true, and then again these two are false. What is negation R? Negation R is F, T, F, T, F, T, F, T. So, if I take the AND of P implies R, negation Q implies P and negation R, because this will give me that S, it will give me the S. So, S is T T F, so this becomes F, again this is F, 1 F means it will be F, again this is T T F, it is F, F T T F, T T F, it is F, T T T, this is only true, T F F F, then T F T, again it is F. So, S implies Q. Now, see this is S, and except this one, all cases it will be vacuously true. So, except this where S implies Q, Q is here this T and this is also T. So, this becomes true. So, I can write this becomes true, and all remaining cases, since my S is all F. So, that S to Q, that means this becomes always vacuously true. These are all vacuously true. So, remaining all cases it will be true. So, what we see that S implies Q, this is a tautology, because it is taking the truth value always true. So, earlier with the same example, using the laws of logic, we have validated the compound proposition, and now with this truth table method, what we have seen that S implies Q is a tautology. So, the argument is valid. So, this is a valid argument. This is a valid argument. Now, to check this valid argument, we will try to frame the laws of inferences, so that our validity of the proposition of argument, or to check the compound propositions, the conditions or the properties will be much easier. So, we will now see that how these laws of logic can be used to combine a set of logic to one laws of inference.